periodic table. So in periodic table, with the help of periodic tables, we can able to know periodic properties and variations of the properties. Okay, people over the years, over the centuries, tried to understand the properties of materials and their relationships. Okay, so we have several elements in chemistry. So in the universe, we have several elements. So they tried to classify them over the years. We'll see how the classification happened. So first of all, what is the need of this kind of classification? The need for classification here is, so we have around 118 elements now. 118 elements. Okay, so if with we have 118 elements, and there are certain similarities and dissimilarities. Okay, so there is an attempt made to understand the interrelationship between them and wanted to classify which element will fall into which category. Okay, so this kind of pursuit was done by several people. So notable people who did the classification of the elements are following: D- Dobrener triads. Initially, Dobrener tried to make triads. It is 1815. Okay, in 1815, Dobrener, what he did was he classified the elements with the help of atomic weight. Atomic weight. Atomic weight. So if you take any, like you take hydrogen, okay, here if you are you this a number will be denoted like this: H1 and 1. Okay, so this is atomic number. This is atomic number. This is atomic weight or atomic mass. This number is denoted as atomic mass. Okay, right? So for each and every element, it will be like that. So initially, Daubener tried to classify them according to the triads. According to the triads. Triads of what? Triads means he tried. Try means what? Three, no? Three. So he took three elements. He took three elements and did average of their two extreme atomic weights. For example, if you take element A, B, and C, he got the properties of B with the help of the average of A plus C by 2. So that in that way he tried, but it is not matching. So it is not a accurate method. Okay, initially he tried to do like that. Next, Newlands came. Newlands also see the atomic group of three elements with similar properties dominate triads only. The atomic mass of middle element is approximated. Okay, to C. This one will be approximated with the help of these two, right? A plus C by 2, right? Next, Newland's law of octaves. What he tried to do was every eighth element, he proposed that every eighth element show the similar property. Every eighth element will show the similar property that he proposed, but it failed with the materials which are heavy. Failed for the materials which are heavy. So in that way, Daubenair and Newland both got failed. So these two were attempts, right? Next, Mendeleev's periodic table. So Mendeleev was successful up to a significant percentage. So first of all, what he did was he made his long periodic table. We call it as long periodic table. Long periodic table with the help of vertical columns and horizontal rows. He tried to group them like this, like a tabular form. He tried to do with the tabular form, and the rule principle followed is increasing order of atomic number. Increasing order. Increasing order means 1, 2, 3, 4, 5, 6. This is increasing, no? So increasing order of atomic mass. He tried. Okay. But what happened? This is also not a exact representation of the properties and variations in the properties. So there were gaps. There were gaps. He actually anticipated that some more elements will be added into the table. So what he did, he left some gaps, some berth he reserved, some gaps he reserved for the future elements. Okay, like for example, silicon, germanium, even aluminum. He left some gaps. Okay, grouped elements with similar properties together. See the classification here. He did it similar, whatever the problem. For example, we have a library, right? You have so many number of collections, right? uh, for example, you have a library, right? You have several books. Let us say you have uh, some uh, thousands, some thousands of books. Okay, it is your personal library. So some books are related to science and technology. Some books are related to arts. Some books are political. Some books are some other category, right? So whenever you categorize all these elements in their respective separate classification, it is easy to access, right? Otherwise it will be chaotic, right? So that is what the scientists are trying to do. We have 118 elements. Unless unless we classify it, it will be a chaotic situation. That too, especially in their right order, right, according to their utilization. So they are trying like that. At that point of time, they were trying like that. So one among them is our Mendeleev. Mendeleev was very successful because first ever classification, very nice classification also. So he has left some space for future elements also. He didn't think that I only uh, discovered everything, this is the end of the table. No, he has not thought like that, but he left some gaps for the future use. Next limitations were anomalous order is, there are difficulties and challenges in the order. Okay, no fixed place for isotopes. Okay, no fixed place, no explanation of periodicity cause. Why you are choosing that periodicity, that explanation also not clear. So these are the demerits of the Mendeleev. So with this context we got modern periodic table. With this context we got a modern periodic table. The modern, who he is called as father of who is called as father of modern periodic table? It is one more question. Father of modern periodic table. Modern periodic table is Henry Moseley. Henry Moseley. Okay, Henry Moseley classified according to the atomic numbers. He observed that atomic numbers are very, very crucial. Without atomic numbers, we cannot classify. He discovered this point. Okay, so if you take any atom, right? Uh, if you are taking a atom, one atom, right, you'll have neutrons, one, you'll have one nucleus, right, neutrons, protons, and electrons. Okay, neutron, nucleus, electrons, and protons. So for in each element, electrons may differ according to the situation. Electrons are free, no. Electrons are very free. Electrons are very free. They may differ. They may differ. Their number may differ. Okay. Their number may differ each time. Okay. So we cannot rely upon the number of electrons. Okay. So that's the reason in any atom, always it will follow neutrality. Okay, neutral. Atom is neutral means what does it mean? There will be equal number of protons and equal number of electrons in one atom. Are you able to follow? Okay. Uh, Protons equals to electrons in every atom. Okay. But what happens in the real time situation while they are moving having reaction, electrons may differ because they will in the valence cell, outer valence cell, it is free, no, it will roam here and there, so we cannot rely upon the number of electrons. So that's the reason we our atomic number is dependent on protons. If you say certain element have atomic number as 21, what does it mean? It means that it has 21 protons. Okay, so in actual sense, okay, in actual sense, even electrons also will be same number only, generally, because it has to follow the neutrality. Okay, so it is supposed to have the same number, but while reaction, what happens, it will roam here and there. So that's why we don't rely on electrons, we rely only on proton has mass is high, so mass of the proton is high. So what happens, it will it won't move here and there, so that number is the reliable number. So he arranged them according to the atomic number, right? So his name is Henry Moseley. He's father of modern periodic table. So what happened next? So how he arranged, that is the story. Okay, that is the subject content. Okay, structure. So he basically arranged the he modified already. Mendel he did, no, Mendel how he did atomic weight, but horizontal only, tabular form only he did. So same thing what he did, same thing he followed. Okay, same thing only he followed, but classific order is according to the atomic number. Okay, number of protons according to the. So he arranged them. How he arranged it? He took 18 groups, 1 2 3 4 5 6 7 8 9 13 14 15 16 17 18. These are 18 groups. Okay, all vertical columns, 18 vertical columns. Okay, right, these are vertical columns are groups, he called them as groups. Whereas horizontal rows, he called them as periods. Okay, these are periods, 1 2 3 4 5 6 7. There are 7 periods, right? 7 periods. So the, we'll see, right? Are you able to follow this one picture? uh, so this one is period 1, period 2, period 3, period 4, period 5, period 6, period 7, right? Group 1 to, right, group 1 to 18. So this is the modern form of classification. Normal denotation is 1 2 3 4 5 6 like this until 18. This is modern form, right? But earlier they used to do it as 1A elements, 2A elements, 3A elements, 4 elements, 5A, 6A, 7A, 8A. Okay, this groups. Okay, so here what we need to understand is they all will have similar properties. Okay, they'll follow some similar properties with a little bit of exceptions. That's the reason we have arranged these things in this manner. Okay, so if you see, this one is there, no, here all these elements in this line, you see, like this, whatever is in this line, H, helium. Okay, both will have same valence electrons in the outer shell. Okay, here one, no, it will also will follow one. Okay, here two is there, so outer shell, this will also have the two. Okay, so in a way, whatever the number here is there, period, same thing, same electron number will be in the outer shell. Okay, fine. Okay, so here we see it's one more things, lanthanides and actinides. Lanthanides, what happened after coming to 56? So all these things are following the same shell. Okay, from 6 to this Rn, radon. From cesium to radon, they have similar properties. Okay, but after 56 they found out that 57 to 71 are not following the same rules. Okay, they are not having the similar properties. So what they did, 57 to 71 they classified and kept it in a different place. Okay, right. Next, 89 to 103 also they saw. Okay, they also are not following the similar properties. Okay, so they made and classified, they separated them. Okay, right. So basically we will be following, most importantly we will be discussing about 1 2 and 13 14 15 16 17 18. These are very very important. Okay, these are the uh, group 1, group 2, 13 14 15 16 17 18. Generally we are going to discuss about these things only. In between things are not very important, not in our level. In 10th level it is not very important. So we can see what else are there in this thing. Okay, right.